So exciting. Okay, derivative of natural log is 1 over x. Okay, ready? In your head. Good, perfect. Don't forget, chain rule is a thing. That's what this says. Don't forget chain rule is a thing. Okay, you guys already know that. Okay, this we've already done. It just has natural log in it, so we'll be able to prove it today. So it's very exciting. So this is the one where it's like 3 to the x or 4 to the x. Why don't we just put an example? Because it's easier when there's like a number in there to like organize your life. So what number? 2? Sure. Okay. So if you took the derivative of 2 to the x, it's literally 2 to the x natural log 2. That's the answer. So it's kind of a weirdo derivative, but it's legit. Then derivative of log. Do they use log very often? Not really. But this will probably be the last multiple choice question is always a really obscure derivative or integral, which we'll talk about later. But like it's always like a random rule that you have to memorize. So since everyone's getting 5s, we're gonna be those people to get. Oh, you think it's a joke? Oh, it's gonna happen. All right. It will happen. All right. So this guy is goofy. That's the derivative. Okay. So ready? In your head. Go. Okay. Good. We're done. Okay. Don't forget chain rule is a thing. Okay. So if chain rule is a thing, don't forget like whatever you're plugging in. Oh, shoot. I usually use red for that. That's okay. Whatever this is. So if it's like fancy, whatever the log of what you're taking, you're going to put that there. So say it was like x squared plus 4. You're going to put x squared plus 4 there. So you're repeating it, and don't forget chain rule is a thing. So chain rule just never goes away. It just learn more rules about it. Okay. All right, let's do examples because the letters, you know how that is. It's kind of a... All right, so number 1. So I did normal ones, and then I did the chain rule ones, basically, afterwards. So, like, the derivative of natural log x, remember? You just had that in your brain earlier. Y prime is 1 over x, remember? That was just, like, in your head, okay? Technically, we're doing chain, but it's times 1, which is stupid to write, so we just leave it, okay? Now, if I had natural log of fancy stuff... Okay, so I had to do the derivative of natural log of fancy things. Now I'm just doing chain rule on it. So I'm going to go 1 over this 2x squared. So whatever it is. So like this one was just x. So I just put the x there. Here, maybe I'll just do that. Put that in red too. Okay. And then take the derivative of x is 1. Like, okay, cool, nothing. This one, now I have to do chain rule on it. So I got to multiply, there we go, by 4x. And then you clean it up. And then that's it. So what is that? 2 over x is the answer. Okay. So that's natural log. Okay. All right, 3 to the x, that's a stick in your brain problem, okay? So again, the exponent's just like basic. So you're going to take the derivative, which this one was like weird because it was 3 to the x natural log 3. That's the formula, okay? So you have that in your brain stuck in there, okay? If I need to do chain rule on x, derivative of x is 1. So I'm not going to write that because it's a waste of time. This guy, the number 4, is like all fancy in the exponent. So this guy is a little fancy. I mean, we've kind of done these type already, but you would do, if you follow the same vibe, it'd still be 3, but instead of the x power, it's going to be this junk. So it's going to be 3 to all the junk up there, 2x plus 1, natural log 3. But then, because the exponent's all fancy-like, you've got to multiply by a 2. I'm going to put this in parentheses so we don't do anything sass like natural log 6. You know what I'm saying? So, is there any questions so far? We're going. Okay. Log base 3 of x. Okay, so for this one again, just throw in your brain. Okay. Don't you love when I say that? Yeah, I knew you did. Okay, so basically the derivative of this, if you just threw this in your brain, be 1 over whatever you're taking the log of. Okay, and then natural log 3. So the base of the logarithm is what you're taking the natural log of. Okay, so that's the vibe for that one. And then this derivative, again, is all fancy like. It's not regular x, it's this goofy stuff. So instead of putting the x there, you're going to be putting in 1 over, and instead of x, you're going to be doing this 5x thing. 5x plus 1. Natural log 3, because that's the base, but then you have to chain it. So because this is fancy like, I have to multiply by a 5. And then I probably put the 5 on the numerator so it looked cuter. Is everyone still alive? Hopefully. 5x plus 1. See, this looks prettier. Okay. All right, so there's like little finagling you can be doing with these. You can use a lot of log rules. So today's going to be the log rule day. So this guy, 2 ways you could solve it. You could do the chain rule on it, or if you recognize it, which I think you should, write this as natural log x to the half, right? And do a little log rule action, because then it's faster. Do you see if I put the half in front? So then when I do a deriv, it would just be 1/2 times 1 over x. Do you know what I mean? So 1 over 2x. Or if you did the chain rule, it's fine. You would just have to be doing some simplifying. So let's say you went straight after it and you did chain rule. It'd be 1 over root x, right? Or x to the half times 1/2 x to the negative half. If I did chain rule on it. So this would be like, if I did chain rule, that's how I would write it. And then it would just take a while to pretty it up. Because you would get 1 over 2 root x times root x, which is 2 over 2x. So I don't know. Whatever your brain does is fine. Just get it right. Okay? Just get it right. I don't care what your brain does. Just do that. All right? So you could do the chain or do your log rules. This thing, you can't do anything. Sine? What the heck? You know? That's a chainy one. Look at all these words I'm making up. Okay, so natural log of this stuff. So that means I'm going to do 1 over whatever this is. That's how you find the derivative of natural log. And then you got to do chain rule on it. So multiply by cosine. And then you can be like, oh, who feels smart right now? Who feels pretty smart? Who knows it? What's cotangent? Don't you feel smart? That makes you gotta feel smart with that. Come on. I'm not circling my answers here. There you go. Yeah, it's cotangent, cosine over sine. Isn't that fun? Okay. Yuck. Look at this one. That looks fun. Okay, so this is fine. We're not going to panic. No one's going to panic. No one's going to panic. The fact that you feel like you're going to panic is a good sign because you know that you're going to have to do what? Quotient, yep. And a chain. So, derivative of the numerator times, there you go. You got it. Natural log of cosine times the denominator minus derivative denominator. Oh no. Derivative denominator. So that'd be what? 1 over cosine times negative sine. Don't forget your little x. All over the denominator squared. This will be fun. Can't wait to deal with this one. Okay, this actually could get cute because the second part is what's giving me heebie-jeebies, but sine over cosine, right? That's not bad. It's not that bad. We're going to have a positive attitude from now on, right? Okay, here we go. This thing. Okay, that's all multiplying stuff, right? This is all multiplying, and then we have the negative in there. So I'm going to change this to plus. I don't like the x at the end. It makes me nervous. So I'm going to put the x first. X first, and then sine over cosine is tangent. Woo! And then we can be done. There we go. Wait, messed up my parenthesis. There we go. That looks ugly, doesn't it? Yeah. That's okay, though. There she is. Okay. That's it. Yeah, we don't need a number. We don't need numbers in math. What are you guys talking about? Okay. All right, next one. I don't know. Can you do that? Do a deriv. Plug in 1. Ready, go. Do a deriv. Plug in 1. You can do it. You guys know things for sure. Oh, whoops. I did that in blue. Don't spoil the surprise. I didn't get it yet.
Oh, so we're just faster than you. We know more derivs than you.
Yeah.
And she's gonna unfreeze it and we're wrong. You didn't get an answer? I'm not bullying. Oh my gosh, I'm so stupid. I didn't even write it out.
Oh, I gave it away that it was a deriv.
Yes.
Because it says instantaneous rate of change.
I feel like a genius. If this is exactly how the AP test is, I'm so impressed. If this question is the entire AP test, I can get it.
That would be nice. Get 100. All right. Did we get B? All right, sweet. Okay, so I told you to take a derivative, but do you see why? I kind of dropped the ball there. Because instantaneous rate of change, that means, okay, deriv. Okay. Also, you get to a problem, you don't know what to do, derivative. I'm serious. They might give you some pity points on something, okay? So just take derivatives of everything. Okay, so good. 1 over the junk times the chain, plug in 1. Okay, here we go. This is going to grow some hair on your chest. You ready?
So we have to do product and quotient.
Okay, so what do we got? Product, chains, quotients, and products. There must be another way. There's another way. This is fun. Write small, okay? Look at all this space. That's how you know it's a good one. Okay. Did I use Y? Yeah. Okay, this is what I'm going to do. I'm going to call it Y. Okay? So, this is what I'm going to do. Y equals, and I'm going to rewrite this, put some space in here. Okay, 2x plus 1 squared 5x plus 4 to the 5th all over 3x minus 1. Don't judge, I'm writing x to the half. It makes me feel better. Because when I do derivs, it's just like organizes my life more. Okay. Now, this is the strategy. If you get a derivative that you're going to have to do that involves the psychoness, okay, little tricks of the trade here is to take the natural log of both sides. Yeah. It's like, oh my God, it's so much easier now. Okay, whatever you say. Okay. Why is this better? Because I'm going to apply my log rules like nobody's business on that right side. I'm going to do all my log rules. I'm going to do the division, I'm going to do the multiplication, and I'm going to do the power rule. So when you did log rules, in Algebra 2 and pre-calc, this is your moment. This is it, guys. This is it. This is it. Okay, so we'll do it. We'll do each step one at a time, okay? But if your brain can handle it, go for it, okay? So this is what you're going to do. You're going to break up the division. It's a lot of writing. Okay, then we're going to break up the division. So this division is going to be replaced with subtraction. Remember all this stuff? Okay, so one of your log rules, you can break up logarithms by subtraction when you're dividing. Now I'm going to break up the multiplication. Notice I keep bringing down that natural log y. We couldn't do a problem like this before because we didn't know what implicit differentiation was, aka sneaky chain. So stay tuned. Ready? Now we're going to break up the multiplication. Okay, so I'm going to write it as natural log of 2x plus 1, quantity squared, and instead of times, I'm going to write plus natural log of 5x plus 4 to the 5th. The minus is from before. Be extremely psycho about that minus sign, PS. Okay? Because you need to make sure that you're not doing anything goofy where you break up that multiplication and then not distribute the negative sign. That would be, you guys would never do that. Never. You would never do that. I knew it.
I'm just gonna change it later.
No, this would never happen to you guys, but I'm just saying, for other people. Like in Mr. Jordan's class, Yeah. All the throwing shade right now. Okay. No, I love them. I do, actually. All right, so now what you're going to do, okay? So is everyone good so far? We did the multiplying and split it with addition. Okay, now I'm going to go power rule. Power rule. Just kidding. Power rule, okay? This one I can't because there's no power, right? So I'm going to bring the half down, bring the 5 down, bring the 2 down, okay? I'm also going to distribute the negative sign because that's making me nervous. So natural log y equals 2 natural log of 2x plus 1 plus 5 natural log of 5x plus 4 minus the lame one that didn't do anything minus 1/2 natural log x. Look at this thing. And we didn't even do a derivative yet. Isn't that cool? We didn't even do it yet. Yeah, we didn't even do a deriv. So anyway, this is the new part of it. So I did all the power rules. Okay, now is the time for the deriv. Okay, now you're going to derive this implicitly. And you'd be like, wait, what? You're going to take the derivative of both sides. So if I take the derivative of natural log y, my natural log y got a little janky over here. Okay, if I took the derivative of it, it would be 1 over y, right? That's like the derivative of natural log. But then times y prime, right? Or dy dx or whatever you want. I'm going to say y prime because there's already a lot of letters going on around here, or variables. Okay. Now I'm going to take the derivs of all these guys. So that should be kind of nice. Well, the 2's just hanging out. So I'm going to go 2 over 2x plus 1, but then chain. Okay, so here we go. So I did 2 natural log of the stuff. So that's where the 2 is, 2 over whatever's in the parenthesis, right? So whatever's in there, so 2x plus 1 times chain rule, 2. So that's the first one. Okay. Then I've got 5, because it's 5 natural log. So if I take the derivative of that, that would be 5 over the junk in the natural log, 5x plus 4 times chain rule 5. Minus, there's just 1 in front, so that's kind of lame. So then this one is just, I guess, the most normal one. 1 over 3x minus 1 times 3 minus, this one, how do we want to do? We could think of this as, this would be 1/2 times 1 over x. How about, maybe think of it that way. Or 1 over 2x, you can go straight to that. Okay, so I'm going to clean it up. Okay. So I'm going to write this as y prime over y. That's going to be weird, but we'll deal with it. Is 4 over 2x plus 1 plus 25 over 5x plus 4 minus 3 over 3x minus 1 plus 1 over 2x. Minus. Thank you.
And you would have got 0 credit.
I know. Seriously. I would have died. I would have done 1 minus. 1 point. 1 point. 1 point. Okay. So this left side, look at that left. What is that? What's going on? Get that y. What is the y there? Okay. Let's just alge it out. Do you know how you do that? You times by y. Multiply both sides by y, right? Because wouldn't that cancel it? And then you're left with y prime, right? But what is y? What is y? Yeah, this is, you go home this weekend, you show your parents this problem. You can be like, look at this. No, they should be like, look what I'm doing, Mom and Dad.
My parents look at it and say this is
Shh. This is useless. Okay, so you know what this y is? You know what it is? Do you know what that y is? Where's y? Where's y? Oh, wait. There she is. There she is. There's y, isn't it? Isn't that y?
Oh my god.
So, I love doing this problem. It's fun. So then you rewrite it. 3x minus 1 square root x. And look at that answer.
That's the answer.
Yeah, that is it. That is the answer. Don't mess up a negative. Okay. So, did I do a little more obnoxious of a question? Yes. Okay. But, okay, if you've got a natural log, okay, so sometimes, okay, so hold on. Sometimes they have the natural log already there. Okay, so no, you should be doing your rules before you start doing derivatives. Okay, so that's the answer. Okay, so when you get psycho, that's this natural log business. Okay, so that's the strategy. Okay, this guy. Okay, now this guy. Okay, there'll be always this kid. Come on. Okay, there'll always be this kid. What do? They'll do y prime equals x times x to the x minus 1 or something. Okay? They'll do like a weirdo power rule, okay?
Why would they do that though?
How do I know it's going to be this strategy that I'm about to do? Is because it's not a number to x, and it's not an x to a number. It's straight up variable to variable. If you have x to the sine x power, if you've got like 2x to the tangent x power, okay? So anything where it's like two variables, this is the strategy. And the strategy is the natural log business. So you're going to take the natural log of both sides. The reason being is you need that exponent down. You can't deal with it right now because there's no fancy rules for those ones. So what you're going to do, the point of doing it is so you can use your natural log rules to get that exponent down. So it ends up being natural, where'd it go? There we go. Natural log y equals x times natural log x. And then you're going to be doing now you're going to do a deriv. So deriv is natural log of y, so it would be 1 over y times y prime perf, yep, equals, silly goose, that's product rule. Okay, product rule. Yeah, calculus is no joke, you guys. No joke. Okay, so derivative of the first, 1. Doesn't work. Come on. It died. It said it was like too much. Okay. Overheating. Yeah, seriously. Derivative of the first times the second times the derivative of the second times the first. So this would be y prime over y equals natural log x plus 1. Okay. So I need to multiply over the y, which would be, if I multiply both sides by y, well, the y is that x to the x thing, which was really weird, but whatever, we're going with it. And there she is. There you go. Yeah. There's a 1. There's a 1 there. Come on.
Pretty much imaginary.
It's a 1. So there you go. There's a juicy. That was a juicy one.